Assalamualaikum warahmatullahi wabarakatuh. Hello and good morning. My name is Muhammad Faisal bin Muhammad Yusof and I am from second year student of Electronic Engineering. So today, I would like to present you about my first assignment under Dr. Liana, which is electromagnetic spectrum. And my further topic is about infrared radiation. So let's explore about this infrared radiation. For the introduction, what is electromagnetic spectrum? Electromagnetic spectrum is defined as the entire distribution of electromagnetic radiation according to the frequency or wavelength. Even all the electromagnetic waves can travel at the same speed of light in vacuum. They can also do so at wide range of frequency, wavelength, and photon energies. And it also consists of many subrange that refer to as portions such as visible light or ultraviolet radiation. For example, the visible light comes from the lamp in our house that we can see every day. On the contrary, we as humans, we are not be able to see ultraviolet radiation because it is undetectable by human eye. However, many animals like insects can see it clearly. So, for the infrared radiation, what is infrared radiation? Infrared radiation is a radiant energy where we are not be able to see through both of our eyes, like I said just now. However, its existence can be proved by the sensation of warmth on our body. Next, radiation has the wavelength range from 700 nanometers to 1 millimeter. Its waves are longer than visible light but shorter than radio wave. Correspondingly, the frequency of infrared radiation are higher than microwave but lower than visible light. Its range is about 300 gigahertz to 400 terahertz. Right now, I will explain you how does thermal imaging work. In this thermal imaging system, it consists of tools that measure second and minute. These are called microbolometers, which is shown in diagram A. This is the diagram A. And one microbolometer is assigned to each pixel. Once the temperature is detected by the microbolometer, it gives its pixel a suitable color. This is how they create a thermal picture. For the second one, a special lens focuses on the infrared light from the emit of all objects in view. A phase array of infrared detector components scans the focused light. The components of the detector establish a thermodiagram, which is a temperature pattern in diagram B. We can see here. It just takes in about 1/30th of a second for the detector array to gain the temperature guidance to make the thermogram. This data is collected in the detector array field of view from several thousand points. So, like I mentioned before, in this thermal imaging system, it has various colors that explain as how much heat it has absorbed. So we can know how much heat in our body, even though we cannot see with our eyes. Next, the detector elements are generating thermogram and later are converted into electrical impulse. These electrical impulses are sent to signal processing unit, which is including circuit board with a dedicated chip that interprets the information from the elements into data for the view on thermal imaging screen. The signal processing unit sends the information to the monitor where it appears as different colors depending on the infrared emission level. The picture is generated by integrating all the impulse from all the elements. And the diagram C, which is we can see here, shows thermal image which is taken with a type of camera involving microbolometer. The orange color, this one, indicates a hot component. The rest of the circuit show blue color related to much colder temperature. And we can see when it show Orange color, it explains us that it has a lot of heat in here, and the blue one is cool the temperature. Thermal imaging commonly used printed circuit board inspection. It enables temperature visualization. In other words, it makes the temperature measurement process which is non-contact method. Next, the use of thermal imaging camera for the inspection circuit board can help with troubleshooting and thermal design for the thermal control in the development of boards. We will also need a thermal imaging software in addition to thermal camera to support the effort as shown in diagram D, which is we transfer it uh, to the software, which easily to know how much heat we can detect in our body. Most thermal imaging devices can at a rate of 30 times per second. They can detect the range temperature between -4 degrees Fahrenheit, which is -20 degrees Celsius, to 3,600 Fahrenheit, which is 2,000 Celsius. And we usually obtain temperature values of approximately 0.4 Fahrenheit, which is 0.2 Celsius. And the diagram E shows us how someone is scanned under thermal imaging to detect the body temperature before they are allowing passes the surveillance area, like in airport or in public shopping mall and others. So we move to the concept and principle in electromagnetics. So infrared radiation in thermal imaging comes from the three laws in physics, which is Planck's radiation law, Stefan-Boltzmann law, and Wien's displacement law. So for the Planck's law, it explains any object at temperature of T is not equal to 0 Kelvin emit radiation, while Stefan Boltzmann law describes the total energy released by a dark body at all wavelengths is totally same with the temperature. Wien's displacement law expanded the theory about some structures of various temperature emit spectra, which is reaching a top of point at different wavelengths. Thus, all objects with a temperature which are greater than 0 Kelvin contain thermal energy and give a result which sources of radiation from the infrared. For the infrared transmission, a transmission medium is required that can consist of vacuum atmosphere or an optical fiber. So the final result, infrared radiation is the thermal imaging is used to detect the intense radiation. Normally the detector output is very tiny and therefore preamplifiers coupled with circuitry are needed to generate the received signal. By then, thermal imaging can be functioned as to detect the heat that is invisible in human eyes. Okay, before I end my explanation about electromagnetic spectrum, which is my further topic is infrared radiation, I will give a bit conclusion about this topic. So electromagnetic spectrum is divided into 7 types, as we know. Those are radio wave, microwave, infrared radiation, which is this explanation, visible light, ultraviolet, X-rays, and gamma rays. Thermal imaging is one example of the useful application that comes from infrared radiation concept. It provided more than one convenience to create more upcoming technology that can be helpful for humans to do further research. This thermal imaging was used by several countries during the epidemics and pandemics, though information on their effectiveness was missed as a part of effort to reduce the disease from spreading out. In Al-Quran, Allah said, I swear by what you see and by what you don't see. God swears by light that we see and by light that we cannot see. Today it has been proved the light that cannot be seen by naked eyes. Even Al-Quran has been released long time ago before scientists noticed the existence of electromagnetic spectrum. In Al-Quran, Allah said, "Fala uqsimu bima tubsirun." Indeed, I swear by what you see. Wama la tubsirun, and by what you don't see, which is the explanation is about the heat that we cannot see, we cannot detect by our naked eyes, but we can use our technology to detect it. And Allah has revealed all of this a long time ago, before the existence of scientists explanation. So that's all for me. Thank you and see you again.